Good
Welcome to APA's
afternoon.
weekly webinar series. My name is Billy Zadig, Standards and Codes Administrator for APA. Just a couple of housekeeping items before we get started. The webinar recording will be posted to APA's webpage later this afternoon. You'll receive a follow-up email in the next couple of days with a link to the webpage where all webinar recordings are housed, as well as links to our upcoming webinars. All attendees are in listen-only mode. Please type your questions in the chat box and they will be answered in the order they are received. If we run out of time and we still have questions, responses will be sent directly to the person asking the question by our presenter. Professional continuing education, ISDs, and AIA CLU credits are being offered. For AIA certificates, please send an email to Billy, B-I-L-L-I-E, @APA.org with your membership number. At this time, it's my pleasure to turn this over to Peter Kesser. Peter, take it away.
Thank you, Billy. Good morning and good afternoon to everybody, depending on where you are in the country. I hope everybody is safe and healthy. That's certainly a big thing these days. Today we're going to be talking about concrete waterproofing, and specifically how to we're going to give you an overview of different types of waterproofing that are out there, but we're specifically going to be focusing on a type of waterproofing that allows you to waterproof the concrete structure once, and that waterproofing will stay in effect for the rest of the design life of the structure. I'm the sales director for Alchemco, which is a manufacturer of waterproofing products, and we're going to be taking you through all of this. I look forward to the questions at the end. So this is an AIA approved course. It is one learning unit, a HSW learning unit. I'm going to be moving through a lot of these slides fairly quickly because there's a lot of slides, and then we'll leave some 10 or 15 minutes for conversation at the end or questions. The course description. So concrete is one of the most utilized construction materials in the world. However, if you want it to reach its potential lifespan, you have to take measures to prevent any premature deterioration. If you think about it, from the time you build a structure, you really have the weather working against you. It's trying to tear that structure down. And so there's a wide range of products that are available in the marketplace to do that. I'm sure that you guys have used a fair amount and have some ideas on which ones you think work well and which ones don't. We're going to go through some of those, and then, as I said, we're going to spend the second part of the presentation more on the product that I want to introduce you to. So it's going to allow you to understand what causes concrete to deteriorate, how we can increase that sustainability and durability, and what are some of the disadvantages and advantages of the different types of waterproofing. Learning objectives are understand why waterproofing is important for the long-term structural integrity of concrete, identify the main causes of structural concrete deterioration, discuss the common types of concrete waterproofing application that are available. For new construction projects, we're going to talk about why crystalline technology can really be a benefit in enhancing the sustainability of the structure. And then we're going to wrap up with existing structures, existing concrete structures, and understanding the difference between crystalline technology that's available and modified silica gel, which is a sprayed-on application. Here's just the table of contents about where the various breaks are. And so we'll jump right into the first one. Why is it important to waterproof concrete structures? Concrete goes back to the Babylonian times. It hasn't changed a lot other than in the 1700s, cement got added into the mixture. While the composition is pretty simple, the modern day versions do have different admixtures that make it cure faster or be waterproof, et cetera, et cetera. Concrete's naturally permeable and porous, so it's therefore full of voids and capillaries and fractures and stuff. These are all pathways for water to make its way into the concrete and ultimately cause bad things to happen. So you've got to make some protection against that. There's been a lot of different types of waterproofing that have been used over the years. And one of the things that we see when we're dealing with specifiers and facility managers like yourself is that there can be an attempt to just fix a specific problem instead, which is really a symptom, as opposed to the real problem that might be causing that system or that symptom. I'm sorry. So until you figure out what that deficiency is and resolve it systematically, you run the risk of water continuing to get into one place and cause problems somewhere else in the structure. Some of the advantages of using concrete: low cost, eco-friendly. You can do a lot of cool things from a formability standpoint, ease of fabrication, but there are disadvantages. Low tensile strength, it's brittle, and it has a lack of long-term durability in its most basic form. That's why you've got to work with it and use some things on it to make it last as long as it possibly can. Premature deterioration can take the form of spalling, cracking, corrosion of the steel reinforcement. Those are kind of the main ones that happen. As I said before, concrete is both permeable and porous. It's almost like a rigid sponge, if you will. And so permeability is that ease of what the fluid can move through the material, the air pockets, the cracks, etc. They not only let water in, they let harmful chemicals in, and there can actually be chemical reactions happening in the concrete over time that will damage it. Porousness is similar to permeability, has more to do with the number and the size of the pores of the concrete. So if water and chemicals are allowed to get into that concrete over time, it's going to cause that structure to deteriorate prematurely. That's going to cause you to have to spend money to either repair it, or if it gets structurally compromised, you may actually even have to tear part of the structure down and rebuild it. Some of those things that cause those problems, again, spalling, stress cracking, freeze thaw, depending on where you are in the country, chloride ion penetration, hydrostatic pressure if you've got tunnels and things like that, and corrosion of the steel reinforcement. So the problems shown in the past several slides will cause concrete to deteriorate. All of those are attributable to allowing water into the concrete one way or another. So to protect it properly, we're going to talk about how that deterioration can happen. Causes of concrete deterioration are weather, so temperature and moisture, improper concrete mix can cause it, chemical interactions, corrosion, carbonation, chloride ion penetration, design flaws, poor construction and installation practices. Any and all of those things can be trouble for your concrete structure. And that's whether it's a tank, a bridge, a parking structure, a stadium, no matter what it is. While concrete can be very durable, it is going to deteriorate over time. Temperature, moisture, chemicals, as we said, all are acting negatively on that concrete structure. Corrosion is one of the big factors, the reinforcing steel that you have below the surface of the concrete. It has a passive layer of cement around it that helps protect it. When that's compromised, either by the pH being lowered to a more acidic type, or water getting in and corroding the steel, it doesn't have anywhere to go. It's going to grow and it's going to pop that concrete, and eventually it's going to spall that concrete away. Carbonation is another form of that deterioration. Again, as I was mentioning, it will lower the pH surrounding that steel reinforcement. It's going to weaken that passive layer. When you've got oxygen and water there, it's going to lead to the corrosion of the steel reinforcement and ultimately damaging the concrete structure. Presence of chloride ions, so this can take a form of seawater, salt water if you're on the coast. Certainly in the rest of the country, especially the northern half, you're going to have the ice melt in the winter from getting rid of the snow and ice. Design flaws, if they're not properly designed for the structural capacity, didn't take into account some of the thermal shifts and movement, or shrinkage and settling, any and all of those things are big problems for concrete. And it can also be poor construction when it was built. You can have pitting and honeycombing, stress cracks, shrinkage cracks, thermal stress cracks. Any and all of those things are going to be problems for the structure. So in order to realize, again, that full long-term functionality, you want to make sure you're using the right type of waterproofing. So we're going to take a look now at what's out there and what you guys have probably been using over the years. You have both integral and non-integral systems. So integral being the waterproofing is inside the concrete, non-integral being it's applied to the surface of the concrete. That can be sheet membrane, that can be liquid coatings, etc. The intent is the same, stop the water from coming in, but they go about it in different ways. So here's a high-level summary of that. You've got your sheet waterproofing membranes. Those can be self-adhesive peel and sticks. They can be torch-on thermofusible. You've got your fluid-applied waterproofing, so that can be hot rubberized asphalt, cold fluid applied. It can be coatings, urethane, epoxy, different types of coating systems. And then you've got your integral waterproofing systems, and those fall into two categories, either a crystalline technology or a modified silicate gel technology. And the product that we're going to be kind of highlighting towards the end is that silicate gel technology, because it really brings a lot to the table. Sheet waterproofing, again, peel and stick, modified bitumen sheets usually. The adhesive is factory applied. You're pulling off a release sheet and you're putting attaching it to the concrete with that adhesive. This can be horizontal or vertical. You have to do proper surface preparations and the conditions have to be right, and you have to hope that the other trades don't damage that membrane before it gets backfilled or covered up. Because that sheet is adhered to the surface, you've got to make sure that there are no voids, and you can potentially have problems with angle changes, expansion joints, the detail work, if you will, or seams coming apart. They can also have problems with abrasion. If something mechanically runs into it, it'll be a problem. Asphalt adhesive gets heated up on a thermofusible or a torch on. It actually melts the adhesive or the asphalt on the back of the sheet, and that's how that gets applied. Because it's applied to the surface of the structure, you have to make sure there's no voids, no way for water to get in. You have to hope that there's no mechanical damage from other trades or something hitting it or puncturing it. And you've always got the potential problem of it bridging around expansion joints or angle changes or perimeter edges. Then you've got your hot rubberized asphalt that gets heated up in a kettle and gets squeegeed out, and this a lot of times is used for plaza decks and things, and it's a very temperature sensitive application. You've got to make sure that it's going down at the right temperatures for it to be applied properly. Just a little more information on that same thing. The cold applied waterproofing membranes, those can be asphalt based, or they can be urethane, they can be epoxies, wide range of different coating systems and traffic coating systems that can be put down. It's important they're going to be multi-layer systems. It's important that the thickness be done. You're manually trying to make sure that the thickness is there at each level to make sure it doesn't delaminate or anything along the way. They're applied to the positive side of the wall in an effort to prevent the water and chemicals from getting into the concrete. And once they fail, once you have a seam split or it gets damaged or it just wears out, that water's going to go through and you're going to end up having to remove that and then apply a new waterproofing system to it. Then you've got your crystalline technology, your admixtures, and these can be put into the concrete at the plant or in the mixers on the job site. They actually get blended into the concrete. They're going to form crystals that grow inside the concrete and block those pores and cracks and things. They're not going to change the visible appearance because they're inside the concrete. You can also apply them to the surface in a dry shake method once the concrete's been poured, and then water is going to carry it in the chemical into the concrete itself, and again they'll form crystals that will block those pores. We'll talk about that a little bit more later. And then there's a slurry that can be used. You can mix this up with water and you can either brush it onto the outside, or you can use an industrial spray rig and spray it on, and then it gets watered and the chemicals again penetrate into the concrete below the surface, and those crystals form below that. Just a little bit more about the slurry. It does change the visible appearance. Usually it's a couple of coats, and as you can see, putting it on, it's if you've got a situation where the structure can't have the visible appearance changed, whether it's a historical building or whether you just don't want it to look differently, then this is not one of the systems you'd want to use for that. Then you've got modified silicate gel, and the modified silicate gel is a spray-on application. Gets sprayed to the surface of an existing concrete structure. It actually gets watered in. We'll have a little bit more on that later. The chemicals penetrate into the concrete, similar to what we were just talking about with the admixture, and it will form a gel inside the concrete that will block those pores and capillaries and microfractures. And so those again are both integral waterproofing systems. So now we're going to take a look at how to make newly poured concrete structures more sustainable. If you remember our fourth and fifth points, one was new construction, the other was an existing structures. So on the new construction, we're talking about admixtures. We're talking about a powder that gets mixed into the concrete. You can see the high resolution photos up in the upper right and left hand corner. Those are actually the crystals being formed in those cracks and blocking the water passage. I would say it's not 100% waterproof. It's certainly a water retardant on its own, and it does a nice job. And if water does get back into the system later on with future cracks, it will form more crystals in those new cracks. So, as I said, the crystalline technology is integral. It can be applied 3 different ways: the surface applied slurry, the broadcasting dry shake, and then the admixture. So in this section, we're going to talk specifically about the admixture. So lots of different types of admixture, as I said before, to speed up the hardening of the concrete, etc. This particular one is for waterproofing the concrete. It mixes with the free lime in the concrete and the active chemicals that are in the admixture combined with the water, and they form those crystals. Rather than adding waterproofing to the structure afterwards, this is a reasonably low-cost way to waterproof a structure right at the beginning, because you don't have the labor of putting any type of a system on every surface that you want to have waterproofed. Again, this is inside the concrete there. It is normally permeable, vapor permeable, I should say, so it will allow vapor transmission out of the structure if it were to get trapped. And unlike waterproofing systems that are added after the concrete is already in place, again, there's virtually no labor. There's just the pouring it, dumping it into the mix, and then letting the concrete get poured. That because of that, you're not relying on the workmanship of the laborers. It's very durable. It will last as long as the structure does. It's not going to tear, delaminate. You're not going to have seams splitting, anything like that. And it is VOC free. So if you do have to demolish the structure down the road, it's recyclable. You don't have to do anything to it before you can recycle it. Here's a partial list of the types of applications. Anywhere really you're pouring structural concrete. So potable water tanks, elevator shafts, water storage, containment systems, foundations, slabs, basements, swimming pools, any and all of those. So then the fifth section here is the modified silicate gel versus the crystalline technology, the slurry, if you will. We're going to compare those two at this point for existing structures. So modified silicate gel, in our case, that is, we call our product Techcrete 2500. As I said before, it's a spray applied. You can see on the left, the gentleman's actually spraying it right out of a 55-gallon drum. On the right two photos, you see people with backpack sprayers on, can be put on horizontal surface or a vertical surface. In fact, the one on the upper right is actually at the sea off the shore of Hawaii. This was a particularly interesting project because it was a floating dry dock, which are normally made out of steel, so they lift ships out of the water so you can work on the hull. This one, they had actually made the hull out of concrete, and so they expected it to last 100 years or more rather than 20 or 25 years like the steel ones do. They put it in the water, it started leaking, and so they pulled it out of the water immediately, spray applied the Techcrete 2500 to it, and within a day and a half it was ready to go back in the water and hasn't had any leaking problems since then. This is just a brief video clip of what this looks like. Well, it was a brief video clip. I guess the video link is not active. So this was just a 30-second video clip showing how easy this is to spray down. This goes down about 200 square feet per gallon, so pretty good coverage rate. It's a very fast application. This product, with one guy, you can cover up about 3,000 or 4,000 square feet in an hour. And spraying out of the barrel, you can cover up 15 to 20,000 square feet an hour. So it's a very quick application. Following the application of the spray on, you let it dry. Usually that takes a couple of hours depending on the weather conditions. If there's sun, if there's breeze, it'll go a little faster. If it's humid, if there's no wind, might take a little bit longer. Once it dries to the touch, then you water it in, and it's literally what it sounds. You're just taking a hose and you're watering the area, and that is driving the chemicals into the concrete surface, below the surface, where it forms a gel that about 1/2 inch to 3/4 inch below the surface, so in between the surface and the steel reinforcing bar. It actually acts as a densifier also. So it would take normally, say, a 3,500 psi surface concrete, and it would test out at about 5,000 psi after the product's been applied. Okay, so we're going to do a little bit of a comparison here on the crystalline slurry versus the spray on. As you can see here, the slurry can either be brush applied, which is very labor intensive, generally figuring maybe like about 6,000 or 7,000 square feet in a day versus 3,000 or 4,000 square feet in an hour. Even with the spray applied rig, it's a very labor intensive application. Both of these applications are integral, so they're both working inside the concrete, so they've got the advantage of no seams, low overall cost, negative or positive side applications, protects the reinforcing steel from the corrosion. They're both environmentally friendly, and they're not compromised by poor site conditions, poor membrane workmanship, or damage by other trades that might happen. Both products have been around for over 30 years. They both use water, which is usually the enemy, but they both use water to migrate the chemicals into the concrete so that it can do its work. In both cases, you've got chemical reactions happening inside the concrete. Again, on one side, crystals are being formed, on the other side, a gel is being formed. and they both leave those chemicals behind, so that if and when a new crack, I should say when a new crack appears, because we all know concrete cracks. And so when a new concrete crack appears and water finds its way into the structure, it's going to hit those chemicals, and it's either going to form the crystals or it's going to form a gel and block that crack, assuming that this is not a structural crack caused by an earthquake or something, and it's just too big of a crack, or an active crack where it's just going to keep going. But stable cracks, hairline cracks, they're going to continually heal themselves over time. They differ from just regular concrete densifiers in that they're A, densifying, but B, they're waterproofing the concrete. And as I said, they will continue to react over and over for the life of the concrete structure. In fact, the spray applied, that we're going to get into a little bit further, actually can qualify for a 15-year full system warranty, labor and material. And the new construction projects, if you use the admixture and use the spray applied both, so kind of a belt and suspenders, that can qualify for a 30-year full system warranty, labor and material. So that particular product's been out there for 40 years around the globe, so it's got a great track record. And so the confidence is high enough to be able to offer those manufacturer's warranties for the full system. Both products require proper surface preparation before applying the products, and that surface preparation is going to vary from project to project. You know, you might have a newer parking structure where all you have to do is power wash it first, or you might have something that's been there for 10, 15, 20 years. It might have previous concrete waterproofing, say coatings, traffic coatings. Those are going to have to be shot blasted off or ground off, so you get to bare dry concrete for both of these types of applications. Some of the advantages of the modified silicate gel: it's fast application. As I said, you can put down over 15,000 square feet an hour. In fact, some of the high production crews that have the spray bars and stuff are closer to 40 or 50,000 square feet in an hour. So they really can cover some ground. It's a very simple system to put down once you're trained to do it. It does not change the appearance of the concrete. Once it dries, it looks exactly the way that it did before. So if it is a historical building or something, and it can be used on their masonry products and for brick and masonry as well, you can waterproof and seal those surfaces without changing the appearance of the structure. And after you're done with it, you can paint over it, you can put a coating over it if you want it to look a certain way. If you're in a traffic area, you could put down a coating with slip resistance, because this is not going to change the slip resistance. The waterproofing itself does not change the slip resistance one way or the other. Doesn't make it more slippery, does not make it less slippery. So the really neat thing about this is this will seal cracks, and when it's applied, it will seal cracks up to 2 millimeters wide, which is about the width of your car keys. It's a pretty good sized crack. And afterwards, as I said, if you get hairline cracks after that and water migrates in, it will hit the chemical, the gel. It will create new gel inside that crack and seal it up to 0.4 of a millimeter. And that will happen repeatedly for the lifetime of the structure. In fact, we've got a white paper on it that shows how the chemical reaction actually works. So you can take a look through that if you're interested. As I said, it increases the hardness of the concrete, the surface, 6 to 8 on a Mohs scale. If you're thinking PSI, as I said, that would typically be a 3,500 PSI would test out at about 5,000 PSI. So it makes that wear surface more durable, particularly like on a parking structure. Crystalline products probably shouldn't be used in structures that are going to have constant movement or have high thermal stress, because they're crystals, it's rigid. The modified silicate gel is more flexible and has better processes for that. So some of the pros and cons on the modified silica gel. Fast to install, very simple spray equipment. This can be done by certified applicators to get the warranty. It can also be done by maintenance crews. If you're not interested in the full system warranty, you can train the crews very easily how to put this down. It resists extreme hydrostatic pressure, becomes part of the substrate. As I said, it's reactive. It will seal cracks 2 millimeters wide to start, and then 0.4 millimeter after that. It is vapor permeable, so it allows outgassing. It's highly resistant to chemicals. It's non-toxic, and it is VOC free. So no matter where you are in the country, even California, you've got no VOCs with this. So we have no odor issues, things like that. Can't puncture or tear or come apart at the seams. And as I said, there's no loss of slip resistance. There's no costly priming or leveling that needs to happen. All you need to do is clean the surface to make sure you've got clean, dry surface to work with. You do need to remove, like say, paint or coatings that might be there, because that's going to prevent the chemicals from getting in and creating that gel. It can be applied to the positive or negative side, although we do really recommend the positive side. There's a number of reasons for that. We really want to prevent the water from getting in the first place. Increases the hardness, less costly to apply, not subject to deterioration, so it's a permanent solution. Increases the bond strength, and one of the things that I didn't put down on here, but it is water potable tested. It's passed NSF 61 at Underwriters Laboratory. Really, the only con is the concrete surface has to be dry before you do the application. So when you're doing the initial application, you got to kind of watch the weather, and then in between each of those applications, you've got to let the surface dry to the touch. And again, in Arizona, that might happen in 45 minutes. In Florida, with the humidity and stuff, that might be more like 2 hours. Of course, if you're in a breezy area or the sun's on it, it might be faster. Some of the advantages of the crystalline, the surface applied. Again, we're talking about the slurry coat. So it's a cementitious slurry coat. It can be used above grade or below grade. Sometimes a single coat, usually it's a double coat. It prevents the water and other liquids from coming in any direction. This particular product can be used on the positive and negative side pretty much equally. And it does not have a problem with wet surfaces. They actually want you to wet the surface before you put it on. So some of the pros and cons there. It resists extreme hydrostatic pressure, becomes part of the substrate. It'll seal hairline cracks up to 0.4 millimeters. That's the limit. So the spray applied is 5 times, it'll bridge gaps 5 times as big. Allows concrete to breathe, highly resistant to chemicals, non-toxic, does not require a dry surface, you can't puncture it, no costly priming or leveling, can be applied to the positive or negative side, as I said. Some of the cons, slurry coats applied to the face of the concrete, so you're going to change the appearance of the structure. It's a slow application, it's labor intensive. The spray application requires specialized heavy-duty spray rigs. Shouldn't really be used on projects where there's going to be a lot of building movement, and the projects may require 2 coats, and if you don't get the thickness right, sometimes there's a danger of that peeling off. So some case studies here, both admixture and topical applications. And in this particular case, these are all projects that Chemco had done around the world. There's some interesting case studies here, though. This one is a hockey field, field hockey field over in Australia. This is at a school. It was done in 2014, so 6 years ago now. They actually poured the concrete with the concrete admixture in it, and as a post-tension cable concrete slab. They didn't have room to build a hockey field, so they did it over the parking area. They just built a slab over it. The reason that I think this is so interesting is the same design consultant builder did this same exact system at a different school back in 1995. So another 20 years past that, and it had worked out so well that they said, let's just go ahead and do that again. This is water cooling tower tanks down in Paraguay. That was done in 2017. This is also an admixture, so these were poured with the admixture in it. And again, the water potability being one of the key things here. The rest of these applications are all the spray applied product, the modified silicate gel, our Techrete 2500, if you will. So Lowe's corporate headquarters in North Carolina, the two parking structures here on the left is about 95,000 square feet. That was done back in 2006. Miami International Airport, this is actually a really interesting one. They did two complete parking structures, all 7 levels of both of them, about 700,000 square feet. They did one of them in 2010, the Dolphin and the Flamingo parking ramps. One was in 2010, the other was in 2015. So they got good enough performance out of it over the 5 years that they felt comfortable doing another parking structure with it. Some of the things they were fighting here, high humidity, a salt environment because it's right by the ocean. There was jet fuel residue that they were battling and other contaminants. So this is, like I say, kind of an interesting project. This is the Peterson Event Center at the University of Pittsburgh. This was done in 2007. They did the concourse and the decks and the steps outside, the 48,000 square feet about. And this is one of a number, you guys be interested, this is one of a number of different university projects that have been done and are ongoing. Well, we just did a few at Purdue and Indiana University last year, doing some more actually right now. They just approved a tunnel. Colorado State's got one coming up. Iowa State is looking at one. Louisiana State is doing a parking structure this summer, assuming that everything unlocks and they can actually go ahead and do all of those. So this really is starting to grow within the university community. This is a parking structure on the ocean, again, Atlantic Ocean down in Myrtle Beach. It was done in 2006. This is another kind of interesting one to me. This is over in Sydney, Australia. It's a resort over there. And this pond is built over an underground parking structure. So the bottom of the pond is actually the ceiling, the top layer of the parking structure. This was done in 1988, so you're talking about over 30 years now with no leaks and environmentally friendly, if you will, because you got plants growing in it and fish swimming in it for 30 years, plus the hydrostatic pressure that we were talking about. So it brings a number of different things into account. This was another parking ramp over in Australia that was done in 1988. The neat thing about this is it was leaking. They had cracks. They applied the Techrete 2500 to it, stopped the leaking. 5 years later, they came out and did this test with the PVC pipe. They put 3 of those pipes over the existing cracks that had been leaking and 3 on the regular surface. Didn't have any leaks. That was 5 years after they put it on in 1993. Then again in 2017, so again 25 years later, they had another engineering firm come out and do the test again. And again, with no maintenance, they had no water leaking in through the concrete. So 30 years without any interim maintenance. This is Northside Hospital parking structure in Atlanta that was done back in 1999. The engineer there liked it because he wasn't particularly fond of polyurethane as traffic membrane. He said they don't really go together. He loved the fact that this was inside the concrete. This is the garden communities out in San Diego. This was a new construction project, 300,000 square feet that was done in phases over 3 years from 99 to 2001. They did podium decks, they did walkways, they did parking structure, pond tested it. This is an oil terminal down in Brazil that was done in 2010, and this really speaks to the chloride ion. You're fighting the salt water here, obviously. They wanted to protect the concrete from that. Pittsburgh International Airport, this really speaks to speed. This was done back in 1986 when the runways were all concrete back then. But they did 1 million square feet of runway, and they were able to do it in 72 hours. So one of the things I'd like to impress about these applications are the speed that they go down at. They go down at least 2 to 3 times faster than the traffic coatings do or any of the other systems. And so your downtime, if you're shutting down a parking structure or a water tank or a bridge or whatever it is that you're having to work on, the downtime is so much shorter, and the trafficability happens within hours. So you can even do projects in the evening and allow people to walk or drive or park on this during the day and then do the next steps in the evening again. So it's very user-friendly in terms of not having to shut facilities down. Wahoo Water Park, this is actually over in Bahrain. This is in an indoor mall. They built this water park, and the waterproofing for the 200,000 square feet of the water holding areas was the Techcrete 2500 product. This is a dinner theater down in Pigeon Forge, Tennessee. They had built a diving tank. You can see in the lower right-hand corner here. They had built a diving tank as part of the show. They dive off those towers into it. It was 20 feet deep. They built it. They were having to fill it back up every single night. Water was leaking out of it. So a couple of years later, they drained the tank. We had the contractor come in and he sprayed the tank. Within 48 hours, they were able to resume their operation. So again, there's that downtime. I don't know how much money you lose by having to shut your dinner theater down for a week as opposed to 2 days, but I'm sure it was considerable. Here's a soccer stadium. I know you guys, a lot of you have stadiums on the campuses. This was built in 1936. In 2010, they did an acid etch, which we've also got an acid etch product that's very, very safe and user-friendly. But they did an acid etch to get a clean surface. Then they did 160,000 square feet of the stands, removed all of the seating, did that. Then they came back and put an aesthetic coating over it because they wanted to have the different sections, different colors. And they also put in some traction surfacing on the steps and the walkways. And then now, as you can see, they're putting the seating back in. So in fact, we're just in process. I can't show you in this presentation, but we did a demonstration for Iowa State University here a few months ago, right before winter closed in, and at their basketball arena on one of the pedestrian walkways. And they now are not only talking about the walkway, but we're talking about redoing substantial parts of the football stadium, the original part that's 50 years old. Piedmont Hospital, this is 2 different parking structures, 163,000 square feet back in 2000 and 2001. And then finally, this was a new construction bridge over in Vietnam. It was 1 million square feet of bridge that was done in 2013 and 2014 that connects Hanoi City with the international airport there. So, as we had started out saying, there's a number of different types of systems that can be used. None of them are right for every single project. So it's important that you talk with some experts and find out what is going to work out best for your particular situation. Hopefully we've showed you some pros and cons to consider, particularly with the Techcrete 2500 product. And we're very happy to answer any questions that you have either now or individually by having salespeople come out or do presentations via Zoom with your people, however you'd like to handle it. So that is the end of the AIA presentation. I wanted to show you just really quickly Alchemco has an entire waterproofing system. This is just not a product. So we've got the cleaning products, the repair products, the flashing products, expansion joint system, coating, etc. So it's an entire system, which is why we're able to offer the full system warranty. And with that, I think we've got about 15 minutes left. I'll open it up to questions.
We have quite a few questions for you, Peter. Can waterproofing be applied to damp concrete?
No, it needs to be dry to the touch. So you don't need to put a moisture meter on it, but you do want to have a dry surface. Otherwise, what'll happen is the chemicals won't penetrate into the concrete and they'll gel up on the surface, and then you'll have to redo it.
Okay, thank you. For integral waterproofing crystal or gel, which is more acceptable architecturally speaking?
Say that again.
For integral waterproofing crystal or gel, which is more acceptable architecturally speaking?
Oh, so from an aesthetic standpoint, they would really be identical. They're both going to penetrate in. They're not going to change the way the surface looks. If you use the slurry, you would change the appearance. I would say that the crystalline formula is more of a high-level water retardant, whereas the gel is an actual waterproofing product, and it's going to last for the life cycle of, or life design of the structure. So if you do this, if you figure a structure is going to last 50 years, and a lot of the engineers we talk to tell me that they design these to last 50 or 60 years, if you put this, whenever you put this down, it's a one-time application. You're going to be waterproofed for the remaining life of that structure. So if you look at that compared to a traffic coating that you may have to, for instance, put down every 10 years, or even like a silane or siloxane that you have to put down every 2 or 3 or 4 years, over 50-year lifespan, you're talking about doing it, 4, 5, 6, 10 times. This you're going to do once. So from a standpoint of budgeting and from a standpoint of interruption of service, doing it once is generally better than doing it a bunch of times.
Okay, thank you. What are the annual maintenance requirements?
There aren't any annual maintenance requirements for the waterproofing. They would stay the same. For instance, if you've got a parking structure, I'll just use that as an example. You've got a parking structure and you have somebody come in, or your team goes and pressure washes it twice a year or something like that, you would want to keep doing that. I mean, again, we're not going to change the way the structure handles, other than the concrete will now be waterproofed.
Okay, thank you. We have concrete cooling tower bases. What system type is recommended for that application, keeping in mind the use of primary and secondary biocides as well as corrosion inhibitors?
Yeah, so when we're looking at tanks and what's going to be in them, what we do is look at those on a case-by-case basis. So I would say that in each of those, we would contact our technical department, let them know what is going to be in the tank, and then we can address that, give you the answer to that.
Thank you. Next question. Would you please describe surface preparation for panelized systems?
So what's important for us for the spray-on product is to have the pores open and have a clean surface. Anything that's going to prevent water from going into the concrete is going to prevent our chemicals from going into the concrete. So if there's any type of coating that was put on initially when the panels were put together, or a paint or a coating, it would want to be removed. And again, the way you would remove it will go all the way from having to grind it off or shot blast it off or etch it off to maybe just using a detergent cleaner and a power washer. Just depends from project to project. In fact, we've even got an emulsifying cleaner that will will pull oil and gas and radiator fluid and stuff out of the concrete, so that then the waterproofing chemicals can go into the concrete.
Thank you. Our next question is this applicable to brick, and also is it only for exterior application?
So it uses in large part calcium to react with the chemicals to form the gel. So in the cases of brick, and we have a specific masonry product that's used for that, it's waterproofing the mortar, if you will, and helping to seal the brick. And so for those applications, we would really look at this as a water sealer, as opposed to a waterproofing product like you would have with structural concrete.
Okay, thank you. After the modified silica gel is put on, what happens if you have to drill it? Do you have to spray it again?
So when we do any projects, we have flashing material. It's kind of a redundant waterproofing, if you will, that gets used at any angle changes and around any penetrations. So I'm not sure exactly what the question means, but when you say drill, if you were like drilling it so that a pipe could come through or a drain could be put in place, then you would want to flash around that drain or that pipe. But again, that's a very easy application. It just goes out, you just go out and do that with a roller or a brush.
Okay, thank you. Can this be used to prevent ice from adhering to the surface?
No, it's not, as I said before, it's not going to change the surface in any noticeable way. It's not going to look different. It's not going to be slipperier or less slippery. It's not going to get dirtier or less dirty. It really is going to go right through the surface into the concrete, and the net result is going to be like you can't see that it noticeably did anything.
Okay, thank you. Can it be applied to stamped concrete?
Again, the only thing that that we have any issues with is if there is some type of a coating or some type of material that would prevent water from getting into the concrete. If you take a glass of water and pour it on the concrete, if it goes into the concrete, then you're going to be just fine with using our stuff. If it beads up, then there's something preventing it from getting in, and whatever that something is would need to be removed so that the chemicals could then penetrate into the concrete.
Thank you. Like painting, how do you know if you missed a spot, and can you go back to it?
Yes. So when I said it doesn't change the appearance, it doesn't change the appearance for the long term. When you spray this on, it'll be a little bit darker for a couple of days until all the watering is done and some weathering. So it's enough of a difference that you can tell that you sprayed here, but you didn't spray there. And the second answer to the second part of the question is yes, it's no problem at all to go and just spray that area that might have gotten missed.
Okay, thank you. Could the gel product be used on stucco?
We don't recommend it on stucco because, again, it chemically reacts with calcium to form the gel, and we haven't really tested with stucco to see if we would get the kind of reaction we'd want to say we're waterproofing it.
Thank you. What type of product is suitable for waterproofing underground tanks to store seawater for lab facilities?
This would be perfect for that. This would be absolutely perfect for it. You would want to, you might want to actually waterproof the inside and the outside of the tank so that you not only keep the salt water in, but you prevent any groundwater from migrating in from the outside as well.
Okay, and our next question is, can this waterproofing method be used on older stone/rock type foundations?
Yes, it can. Again, it's more of a water retardant there than a waterproofing. The waterproofing is a function of the high density of the structural concrete and the calcium that's naturally there. So when we get our water in, our accelerating agent, and it forms that gel, uh, that's really the true lifetime waterproofing. But I think I've answered the question. It can be used on older stone, and it will help. It's just not a 50-year type of thing.
Okay, thank you. Your next question is, the Northeast has winters that have major temperature swings, causing contraction and expansion. Are these applications you mentioned applicable to this problem?
Yes, absolutely. No question about it. Now, I will say, let me add one more thing. This is a temperature sensitive product, just like many construction adhesives and fluids are. So the recommended temperature range for applying this product is 40 degrees Fahrenheit and rising, which is with a lot of construction materials. So you wouldn't actually be applying it in the winter up north. But yes, once it's applied, it reacts very well to the temperature swings.
Okay, thank you. And someone just said, I may have missed this, but can it be applied to water damaged concrete with effervescence?
So you're going to want to clean that as much as you can. Again, it might be an acid etch, it might be a shot blasting. The real litmus test for us, and what we always say on any project is, and we have the contractors do this too, is to go out and pour water on the surface. If the water will penetrate into the surface, then our chemicals can penetrate into the surface and form a gel. If they can't, then whatever is preventing that from happening has to be removed.
Okay, thank you. Are there any hazard chemicals released during the application? What about during demo of concrete with this product applied?
No, there are none, and it is the concrete is completely recyclable without having to do anything.
Okay, thank you. We got time for a couple more questions. Are there any complications while striping? Let's say parking spaces, bonding paint to surfaces.
Yeah, so there aren't any problems with that. What we recommend and what we require, if it's a full system warranty, is that the striping be removed, the waterproofing be put down, and then the striping can be put back down, because the striping will prevent the chemicals from getting into the concrete in those areas. Now, if you're not interested in having the full system warranty, it can be and has been many times applied with the striping still there. And as long as the striping is there and preventing water from getting in, you're fine. If it wears out or if you move it, then at that point you would want to spray those areas because they wouldn't have gotten waterproofed in the first place.
Thank you. Next question. Will this help eliminate effervescence in CMU walls?
I think I would have to get with my technical director and ask that question.
Okay. And that seems like it concludes all of the questions. I have a few that I need to forward to you for response, but I would like to remind everybody that the webinar recording will be posted on our website later this afternoon, and I will have certificates out to everyone in the next couple of days. Peter, thank you so much for the great presentation. I'd like to thank everyone for joining us today. We'll have a town hall on COVID-19 tomorrow, and they'll be talking about human resources. So Thank you so much for attending, and we look forward to seeing you in the future.
Thanks,
Bye-bye
everybody.
now. Be safe and stay healthy.